let's start with PA2. So I graded those up, and those looked good, as I'm coming to expect. So, general issues with PA2. This was a program where in most cases it either works or it doesn't work, right? It's going to blow up horribly, or not run at all or something, or it's probably going to be 70-80% correct at least, and in most cases it was the latter. So let me go through my implementation of PA2, and keep in mind, right, there's a lot of ways to do this, but this is an implementation along the lines of what we've been talking about in class. So this was my standard test code, which most people just included in their submission, which made things easy. But create an index utility, call the build index method, and take the word list it gives you back and print it using the print method. So index utility has to keep track of a handle to the main list. Okay, so I've been calling it the list, but you can call it handle or root or whatever you want. I decided not to use sentinels in here. Nothing wrong with using sentinels, okay, but just to mix it up. So there's no sentinels. So the list is going to be null originally if you don't have a list, which I forgot to set it to null, but that's okay. And I had comments. So the only real method in this class is the build index method, right? This is effectively your main program. And it sets the list equal to a word list. I don't know why I did that. Instead of making it null. Oh, because it's a word list. Okay. So so the list is a word list. Okay. It's not going to be null even if the word list itself is null. So let's be careful about this. So your word list is these three-part things. And these are your position list. Right, so word list is this stuff. And I suggested that you're going to want separate classes for your nodes in addition to your lists. Not everybody did that. Some people use the word list as both the word list and the nodes of the word list. You can get away with that, but it's a little mixing two different things into a single object type. All right, so the list is my word list. You initialize it to an empty word list. Set up a scanner on standard in. Set up the counter for the words, and then this is the whole guts of the execution. So as long as there's another token, grab the next token, convert it to lowercase, add it to the list using the add method with a position of pre-incremented word number. A fair number of people used next line and then started tokenizing the string manually. You can do that. I didn't take off points for it, even though in some cases you weren't tokenizing it quite correctly, because if you split it at spaces, then you're going to pick up a tab as part of a word, and you're really supposed to split it white spaces. But next and has next, right, break it up by the default delimiter, which is white space. But if you pull in a whole line and split it up, that's okay. So the split method is handy. So this loop keeps calling the add method on the word list. When it's done, it closes it and it just returns the word list. So the word list does most of the hard work. So it has a header, which is null originally. When you add a string, if the header is null, we make a new word list node, and that becomes the header, and you return from there. And the word list node constructor takes a word and it takes a position, because the only time we're going to try to construct a new word list node, we're going to know what position we're trying to store that word in. So if the list is empty, we make one word list node, and that's the whole word list. Otherwise, I did the thing with the previous and the current pointer. So I started current here, and the first time through I set previous to null. But then after that, as I move through, previous will be the prior node, current will be the next node, and we're trying to find a spot where we're inserting in between previous and current. So we compare the word in the current node to the word we're trying to insert. And if current comes after, then we know we're at the insert point. So set up previous and current and go through the list until your current node is null, which means you ran out of nodes, didn't find it. So the compare to method, compare the word in the node to the word we're trying to insert. If it's positive, we want to insert before the current node. Okay, so at this point, we've got a previous node and a current node we want to sandwich in between there. And there's two possibilities. The first possibility is that you're actually inserting before the first word in the list, in which case previous is null. So this is a special case. The other case is just where somewhere in the list, previous and current both point to legitimate nodes in the word list. So we just check for those two cases. So if previous is null, then we want to insert before the first node, so we just set the header equal to this new node, and we're done. And we already set new node to point to whatever the node is we're inserting before. Otherwise, if previous is not null, then we just set previous to point to the new node. And in either case, we return. So that's all inserting before current. Otherwise, check to see if the current node's word is the same as ours, so use the equals method, and if it is, then we just want to add a new reference. So we go to the reference list in the current node, the position list, and we just call the add method and return. Otherwise, move the previous and the current down one spot, go back up to the top and keep going. And then down here, you've fallen off the edge of the list, and so we need to take the end of the list. So at this point, if this is null, this was previous, this was current, and we looped until current was equal to null, so we want previous is next to point to our new node. So we set that up right here, and then you're done.
You just go up a little bit.
Mm-hmm.
I was curious about the compare to, because I thought maybe I was using previous instead of current.
Okay.
But I don't think it's how I did it.
Okay. There's different ways. You can avoid the 2 pointers if you just check one spot ahead.
Yeah.
But then you have a bit of a special case the first time through.
And I also thought maybe it was a problem with how I did, because I used a sentinel node.
Okay.
But, yeah, and maybe that's the issue, who knows.
Did yours not work?
Mine was the one that you said the code looked correct, but it didn't work
Oh,
for some reason.
okay, okay.
So we weren't sure exactly what.
Yeah, come by, we can go through it.
Yeah. You're in today, right?
I was.
Tomorrow then.
I'm teaching till 4 from this point. Oh no, I'm in 11, yeah.
Oh, okay.
All right, and then the print method is pretty straightforward. All right, just go through, start off at the header, and while it's not null, print out the word, and then a colon, and then I just printed out the position list, which I called reference header. And I'm just going to punt to the toString method in there, and that'll be my comma separated list of positions, and then move down to the next node and keep going. So that's the word list. Word list node is trivial. It's a word, a position list, and a pointer to another word list node. And the constructor, you pass it a word in a position, and it does everything it needs to do. It stores the word, sets the next field to be null just for default, creates a new position list, sets the reference header to that, and then adds that first position into the reference list. And then position list, not too bad. So it's got a header, which is, again, the first node or null, so it's initialized to null. When you want to add an integer, create a new position list node. If the header is null, that becomes our header. Otherwise, follow the trail of links down until temp.next is null. Now temp's the last node, so then change temp next to point to your last node. And then the toString method, if the header is null, I just return an empty string because there's no nodes. That's never going to happen. But just for completeness, put that in there. Otherwise, have something that starts off at the first node. Set an output string equal to the data stored in that first node. And then move to the second node, and here we go through a loop. And as long as that node's not null, concatenate a comma followed by that node's data and move to the next node. So that sets my output string to the first node's data, and then for each node after, a comma followed by the next node. And so that gives you comma separation, and then just return that string. And that's the toString method. And then position list node is simpler than word list node. Constructor that stores a number, and it's got two pieces in the node, data and a position list node. That's the next field. So places where I saw some struggling going on tended to look like you had the right code sort of in place, but maybe you weren't sure exactly why all of it was there. Like we talk about constructors, but you don't always need a constructor, and your constructors aren't always going to look the same. Right? So what's the purpose of a constructor? Well, it's how you create an initial object of a given class. But what you do in that creation of that object is totally up to you, right? It totally depends what this object is and what its nature is. And if you don't need to do anything special, you don't even need to create a constructor, right? There's always a default one. But if you need to initialize some things or create some other objects as part of that construction and so on, right, you put those things in your constructor. So in some cases I got fairly deep into people's code, in other cases I didn't. But if your code was not working, you don't know what the issue was, right, definitely come by this week, right, sooner rather than later. And let's go through your code and figure out what was going on. Pretty much all the code I saw, if it wasn't working, it was really close, right? And in some cases, well, he's not here right now. We spent about an hour this morning going through one person's code. There was one extra line of code they had at the end of one routine. They changed the value of their header, but it totally messes up the behavior of the program, right? But it was just one thing, and it was a piece of code that had come in early in like a 10-hour coding session, and it just never got removed. So it's really easy to get sort of lost in these layers of complexity. Another reason why commenting can help, right? If you put a blurb next to that line of code saying why you're doing it, right, it may be easier to see that it doesn't make sense later. So yeah, definitely come and let's debug if you had any issues. So questions about this? Okay.
I have a really quick question.
Yeah.
What is raffles? I was thinking that as well.
Well, It's blah blah. I don't know what in particular it is, but to get onto the internet for a while, there were only certain pages you could use that, there we go. There were only certain pages you could use that would bring up the login page, and so I had a waffle recipe bookmarked, and I used that one day and it worked, so that became my standard for getting the network. So every class began with a recipe for waffles on the screen, so it became a thing in the class. So what should we call our class? And someone was like waffles. So.
Waffles is a great place to start.
Yeah, but it makes you really hungry.
I was just really curious.
Yeah, there's all kinds of things in here. All right. So I want to talk about threads this week. And part of this is to get you through Lab 3. So let me run through Lab 3 really quickly. And then we'll figure out how to make this happen.
Also computer documentation is kind of interesting.
Say what?
Also computer documentation about threads here is interesting.
Oh, okay. So this is another blinking light lab. But the trick is that while your LED is blinking, you can type in a new number of milliseconds to wait between blinks, and it'll change the blink rate. Okay, so it's an extension of part of what you did in Lab 2. Your LED is blinking, you can type 200, hit enter, it blinks 5 times per second. And you can hit 5,000, it blinks every 5 seconds, and so on. But the trick is the LED never stops blinking. It doesn't stop and then say, okay, what do you want to blink at now? Okay, it's constantly blinking all the time, the rest of eternity. But you can still type in a number, hit enter, and it'll change the blink rate. And so this is hard to do in general because we usually do what's called blocking reads. So think about C, you say blah blah, and then you say F gets blah, and then you do some other stuff. And your C program is running, and it gets down here to where you're saying F gets from standard in. And this line of code is not going to execute until the person hits the enter key, right? You can type, you can backspace, you can correct, you can go get some coffee, and so on. And your program is in some sense it's stuck here at this line of code. Okay, it's blocking further execution of your program until this input is satisfied. And fgets comes back after you hit an enter. Once you hit the enter key, now it goes on and does the next line of code, continues doing some stuff, and at some point, if there's another fgets, it blocks at that point also. So if we had a program that was, a C program that was printing out 2 messages and just alternating between them with a time delay, right? So that's pretty easy. So print your first message, sleep. Print your second message, go back up to the top, or sleep again. Go back up to the top. I don't know what I'm trying to spell there. But if you want to change this time interval that you're sleeping, right, you need to do something like, do an fgets how long, and then use that in your sleep. But when you get to that fgets, right, your program's blocked. So it's not going to be alternating these messages until you hit enter. And the most common form of input for high-level languages is usually blocking. Now you can do non-blocking input. You can say, grab 5 characters from standard in if they're available. If they're not, don't wait around for them. Okay, that's a non-blocking input operation. And if you have a non-blocking input option, you can do this kind of thing with a single thread, a single execution context. But non-blocking I/O can be kind of hairy. So a different way to do this is to use threads, and that's what we're going to do in Java. So what's the idea of a thread? It's kind of like a fork in C, but a little nicer to work with. So you're running some code, and at some point something happens, and another execution context starts. And now you have two processes effectively that are both exist on their own, right? Independent of each other in the sense that they both have their own execution environment, their own variables, and so on. But because this original thread created this new thread, it's possible to leave mechanisms in place so that you can have communication between these threads. And you're going to want to do that for Lab 3 also. So creating threads is really easy in Java. Okay, it's a very deliberate part of the language. And if you have multiple cores in your CPU, you may have two threads or more that are actually executing in parallel. Okay, if you have a single core, they're not actually executing at the same time. They're both executable at the same time, but a single CPU, right, it time shares. If you have 100 processes, it's still only doing one process at a time. But if you got multiple cores, right, you may actually have them both running on separate cores. Right?
It's neat that you can still communicate.
Yeah, yeah. All right, so this is a part of Java, and the main thing we're going to work with is a class called thread.
Can't see that button.
Can't see that either. Can't see that. There we go. Main thing we're going to work with is a class called thread. Okay, so it's a Java class like everything. And there's a lot to threads, but we're going to start off with a very minimal set of methods. There's one method we're going to care about in a thread. So let's write some code. Alright, so I'm going to create a class called myThread, and when I create it,
You're doing the package.
yeah. When I create this, I'm going to say extends thread, so that my thread inherits all the things that comes in the thread class, plus some extra goodies we're going to add. So thread, different ways to construct. We're just going to do the default constructor. Lots of methods, very few of which we're going to care about. let's put a method in here. There's a method called go. All right, so nothing thready really happening right now. We're creating a new instance of this class, MT. We're running the go method, and then we're going to tell you when main is exiting. And the go method is going to print 100 integers separated by spaces. And then a new line. So no surprises yet. All right, we run this, it prints out 100 integers. You can trust me that they're over there. And then main exits, and everything is done, the process terminates. Okay, if I call this method run, and in my main method, I invoke the run method, same thing happens. Still no surprises. But if instead I invoke the start method in this new class, something different will happen. Well, let me show you what happens. So I said start, and then immediately the main program said it's exiting, and it said goodbye, and then the run method executed from this class. And that doesn't look like what should have happened, right?
So what's the start method?
So what's the start method doing? The start method is saying create a new thread. Okay, so when you call start, it's kind of like saying fork. It's not fork, it's not cloning, right? But in the sense that when you say start, it's telling the JVM create a new thread. And then it says go ahead and execute the run method in that thread. So start. Does two things.
So if you really wanted the exit message to come after the list, since you've got the two threads, would you add a little sleep method in there? Remove that,
You
or would
could
it still appear.
you could sleep. That's actually a fairly tricky thing to do, though. To get it to wait for this other thread to exit. So you can. Well, let's just go ahead and look at it. Waiting for a process to exit is not too bad, but a lot of this stuff is deprecated. But wait should be available. There's no wait. Yeah, let's not go there.
It's a
join.
daemon
Say what?
thread. Is daemon thread.
Is that demon? How do you say that?
You call it a demon, but it's spelled Damon.
It's probably
So
Um,
what is a demon?
what's a demon? So demons or daemons are these things that run in the background and do stuff for you.
okay.
Right, so SSH is how you do your secure shell login. SSHD is the SSH daemon. Okay, LP is the line printer. LPD is the line printer daemon. So a lot of these things that you do, there's a version of those commands with a D at the end. That's the server generally that hangs out in the background and processes requests. I'm having a really bad morning on Linux because I lost my little buttons up there too. Well, let's come back and talk about communication between threads in a minute. It's okay. So when we say start, right, it's creating a new thread and then running the run method in that thread, which means it's now asynchronous. So let's make 3 threads. Let's store a process ID. So when we construct a thread, we can identify it with a number. And we'll print out that process ID next to the number that it prints. And we'll start all 3 threads, and then we'll exit the main program. And if we run this, we get some differences. So thread 2 started, thread 1 started, thread 1 got to its second number, and then the main program exited. And then thread 2 got to its second number, thread 1, thread 2, and thread 3 didn't even kick in till over here, right? And yes, so it seems kind of randomish. And if we run this again, we get something different because now thread 3 started right after thread 1,
And just 2 takes over.
and then 2 takes over, and
Yeah, that's it.
and
I think you do give each program the equal opportunity.
yeah. So did 2 go all the way to the end? Yeah, it did. And then 3 kicked in, and 1 comes in over here, and then comes back, and so on. And it's going to be generally different every time you do this, right? So it's not random, but it's subject to what's going on in the system and where the scheduler is and all kinds of other things, right? So these are truly kind of independent, separate threads. So disclaimer up front, this can make debugging a nightmare, right? It's not going to do the same thing twice in a row. So when you're developing threaded code, you get really good at coming up with test cases and finding simple test cases, and it's a good chance to get better at sleuthing out sort of where the issues are. Because if you can't isolate the bug, it's very hard. If you can't isolate a test case that reveals the bug, it's very hard to debug. And isolating test cases is tricky with threads, just because it's doing different things each time. All right, it's got the basic idea.
What does run do by default?
By default, it does nothing. So
Well, it does what you put inside of it.
So if we don't write a run method ourselves, nothing happens. Right, so it probably does something, but it effectively nothing.
So is run basically main method?
Effectively, you're going to use it as a main method, yeah. It's the thing that's going to be executed first when you start a thread. But when you create the thread, right, you're still calling the constructor, so you can do initialization in there. Let's just see if this works. It's a horrible try-catch block. Right, so join will basically block until a thread exits. So if you just want to know when threads are finished, you can use the join method. But we usually want more nuanced communication between them. And in general, you don't necessarily want to create a thread and then stop yourself from doing anything until the thread exits, because then you're not really taking advantage of parallelism.
So join's waiting, what join does is it makes main wait until one finishes, then two. Okay.
Yeah.
So is when you're telling the first thread to join, is it also waiting for threads 2 and 3 to wait, or is it just?
The code will actually block at mt1.join.
Okay.
Right. So let's do this. Alright, so it blocked until thread 1 was done, and it turned out thread 2 had already finished. But it doesn't notice that because it's waiting for thread 1. When thread 1's done, then it says wait till thread 2's done, and it was already done. And then thread 3 finished its say. Thread 2 finished out there. But we can do other communication by setting up variables. Right, so how would we do this with a blinking light? So here's your main method, and normally you would do something like LED on, sleep some amount, LED off, sleep some amount, go back up here. And our goal is to be able to change that value of n, so make a new thread. And this thread can say, read from standard in, convert to an integer, and then that's got to somehow get that integer over to here to change this value of n. Well, if this thing has an accessor or a mutator, right, we can just call that. So change n in other thread. And go back up here. So now this code is blocked. It's waiting for the user to type something in, but this is continuing to do the LED blink. When you finally type in a number and hit enter, it gets converted to an integer set to n. Goes back up here.
stop main and say, is there a number yet?
Right.
This is way better than that.
Yep. So that's the excuse to use threads. So how do you change n in this other thread? Well, here's an easy way. So let's call this input thread. Thread.
Right.
Alright, so that's all you need to do. You need to construct a new thread and then say start. But this thread now, so this is in thread, this has got to have some sort of access to this original thread. Well, when you construct, you could pass this. And in your constructor for in thread, you're going to be called with an argument which is a whatever this class is, right? And you can use that to get to a mutator. But don't do it like this. Do it the other way around, because this is going to blow up because of statics. So keep that idea in mind, but let me suggest to you, do it like this.
I was about to say.
Have your main thread be the one that's doing the input. Have your blinker thread do this. Right, because when this thing constructs the blinker, it has access to that object now. And so just make a mutator for n.
And don't you also have to set like a time before it actually starts blinking anyway? So it knows how fast to blink?
You can initialize it to something, 500 or whatever.
So if a thread returns, right, is there a way for main to know that it's dead?
So if a thread exits, right, which is what happens when you return from run, yeah, there probably is, but I don't know those ways because, like I say, half the stuff is deprecated. But you can set a flag, right, and so the blinker could set a flag
Just start.
for main.
Start only runs the run process, right?
Mm-hmm.
Okay.
Yeah. So there's these. So you get an estimate in the number of threads in the current thread group, but not an exact number. And the really goofy part is trying to like terminate threads, because all the good stuff like destroy and stuff you're not supposed to use them anymore.
Well, yeah, I figured you'd have some way of doing it within the thread that you state control on it.
Yeah. Okay, so you can use it as alive to see if a thread's still running.
Great.
And so the sleep method that we've been using inside Lab 2, for example, is just part of the thread class. So that's sleep code. All right, so basic mechanics make sense, right? So you can play with this in Eclipse to get the idea of threads themselves, right? So have a main method, create a thread, run it, that kind of thing. But explore that asynchronicity, right? The fact that the threads are running on their own, and you can't predict when anything in a particular thread is going to happen relative to another. Okay, now for the blinking LED, that's not going to be a big issue. And that's as far as we're going programming assignment-wise with threads for this course. So we're not going to be forced to deal with sort of the more subtle issues and the debugging nightmares and so on, but we will talk about them, okay? And I'll go through an example tomorrow of where you can get into trouble with threads doing their own things and some of the unexpected results that can come from that. And we'll learn one technique for avoiding that, which is synchronization. And so we can actually control when sections of code will run relative to other sections. And that'll take us into some multi-threaded discussions. And then I'm going to finally go back and talk about statics, because we keep dancing around them. And I started seeing people putting static sometimes in their declarations for their PA2 code. And I don't want people doing that kind of haphazardly. So we'll talk about statics. All right, that's all we got today. So I'll see you next time.
I got the